Hey everybody, John Grimsmo here, and I'm working through a little bit of a problem, a challenge right now. So I want to bring you guys into the process and kind of show you what I've come up with. So more than once, I've come into the current in the morning and it's like this. It is mid-cut, stuck, turned off, e-stopped, something went wrong. And well, let me show you what happens. Okay, so here's how it works. When it's machining, the machine is blasting coolant, copious amounts of white liquid, looks like milk. It goes down here. You can see it pooled up at the bottom there. And that is the chip conveyor. So there's the end of it. And it's got a scraper. It pulls the chips that way and the coolant that way. And you can see it goes all the way back. So the coolant goes there and it goes that way. Lots and lots and lots of coolant. Now on our other machines, the coolant, the chip conveyor and the coolant tank are kind of the same thing. Whereas this machine has the chip conveyor tank and then a transfer pump that transfers the coolant to the paper band filtration unit. So where it goes through all the paper and catches all this little, all the chippies. That works great. So this is actually my main coolant tank. There is lots of coolant in there. So since you have a transfer tank here, what you need is you need float sensors. You need float sensors that tell it I'm low and I'm high. So one is continuous duty and the other is overflow. And if the continuous duty gets plugged up with chips for any reason and it doesn't work, then the tank gets too full and the overflow trips and then it e-stops the machine. And like I said, that's happened too many times. So I bet you, I even put thumb screws on this because I have been in here more than once. So I bet you if I pull this off, we should be able to see exactly what I'm talking about. Okay, I've seen worse, that's not horrible. However, I can get it to focus. You can see these are stainless, they're not really magnetic, but chips are sticking to them anyway. And it's failing. Even though it's super free-flowing, in my opinion, it's just a horrible design. You're putting the actual sensing mechanism in the path of coolant and chips, and I don't like it. Now, the chip conveyor, so all the main chips come here, and then it kind of overflows into this little reservoir, but there are absolutely lots of chips in here, and this pump is capable to suck them all up and shove them. I mean, that's why all these chips got pumped by that pump. And that's what the paper filter does, and the paper works fantastically. Yeah, I wanted to show you guys. So all that junky stuff comes through here, filters through the paper. That's what comes out, right? And then the pumps transfer the coolant, and then I added these two filters. Filtration uses these nice bags. In here, maybe we can't see it, but this is an old one, a couple months old. You can see how dirty it is from the grinding, but I looked inside there and there are like 2 chips at the very bottom, if that. There you go, you can see a couple chips at the very bottom of the bag. That is fantastic, which means that the paper band filter is actually catching 99% of the big chips, which is great. And then this is capturing the dust from grinding. And then I got a 10 micron and a 5 micron. Let's see how much chips are in here. I cleaned this out well a week or 2 ago. It's not so bad. But there are chips in the bottom. And they pool, oh, there's way more in the back. They pool right around where these sensors are. Look at that. That's too much. And they go right back here, right where the sensors are. So, I don't like it. I am replacing these sensors. I'm doing something different. I got a couple ideas. So I was chatting with my buddy Mike over at Milterra, and I texted him and I was like, I showed him a picture of the coolant sensor all plugged up. Actually, let's put that picture in right now because I have a picture of it being worse clogged than it was before. And he said, oh yeah, we got rid of all of those sensors. We replaced them all with this. Let's go into my computer here. This is an IFM LR7000 continuous level sensor guided wave radar. Now this thing is pretty cool. It's got the rod going all the way down, which doesn't do much, but it guides the radar waves, apparently. So you cut the rod to whatever length you want to fit the tank you need, and then it's supposed to work amazingly well. Here's a good picture of it. And so it's continuously variable, meaning it knows you're 10% full, 20% full, and you can set your height limits to wherever you want. That's really cool. Now at $600 Canadian, it's not cheap, but it clearly it's the right solution. The problem is that does not salute me today. So what is the solution that I have for today? I came up with this. I was thinking, the float is stuck in the water. There's chips flowing all around it. It's not the right environment for a sensor to be in. How do I raise that whole thing up, call it this much? I settled on 4.5 inches. If I can raise that up and put like a test tube or something stuck to the float underneath, so that the test tube will float on the water and all the mechanism is out of the coolant and out of the chips. I really like that idea. So what kind of test tubes did I have around? Well, end mills come in these tubey things. So I have this bigger one, which will work perfect. Now, let's go back to Fusion and I'll show you what I came up with. So I drew up let me hide some stuff. So this is basically the float as it is. And I put some limits in here and some joints so the float can go up and down. And then this is kind of the tank. I might move the position of it. And if I lift the whole thing up 4 inches, then this is kind of what I'm left with. So my water level is going to be like here. And, how do I attach to that? So I came up with this. If I 3D print a 2-part housing that captures the ball like that, and I put these kind of zip tie channels right there so that I can put zip ties around it and keep it tight, it'll clear the tube on the bottom and it'll hold my end mill box just like that. So this is that clear plastic end mill container, and then I have a split housing that goes around it, as you can see. If I hide one of those bodies, you can see what I'm talking about. And then it'll zip tie together. And I realized this is going to be a problem. That top pin is going to fall a little bit short. I just realized that. That's good to know. Should be fine. We'll see. But yeah, as proof of concept, as a solution finder, I think this might work great. And then the plastic container, literally only the very, very, very bottom of it is touching the water. All the mechanics are out of the water. I think this should work really good. And then since I'm raising the whole thing up, I designed this bracket that basically allows it to clamp down with one screw, get kind of a L-shaped support foot, and then this bracket will attach to the top of that. On my Prusa 3D printer, which is now cleverly positioned on the ground, it is already printing those 2 clamshell pieces that go on there. The bigger piece is going to take several hours to print, so I don't want to do that right now. I tried to print it last night, but I didn't have time. So I'm going to print that overnight, and I'm going to try to see if I can figure something out for today, because I'll probably get the machine running anyway, but it happened twice in a row, 2 days in a row. I don't want it to keep happening. I need a solution now, and this might work. So it's not fun to have the machine e-stop itself in the middle of a cut, in the middle of a program, ruin the rest of my night run. It only did, let's see, I had 3 Rask pallets on for last night. It finished one of them. It alarmed out probably 2/3 of the way through the second one, and it did not get to the third one yet. So I'm behind from my scheduled plan from a kind of a dumb issue, chips wrapping around the float. So I got to fix that because I need it to not happen again. Now with the machine here, I was looking at this, and it is in a roughing cut right now, so it's not in a bad place. If if it paused during a finishing cut and it stops there, you know, the spindle's gonna spin for a second, you're gonna leave a mark. It's just gonna leave a little bit of a mark, depending on where in the program, you know, it might stop during a retract or something, but because we're in a roughing move here, it's fine. So I should be able to pick this up again, rerun that part of the program, and then finish it out. So I'll do that right now. Doing a spindle warm-up. It kind of automatically forces you to do it every 12 hours, 6 hours, I'm not sure, of the spindle being off. So it's like a 3-minute cycle, pretty easy. The starting RPM is 21,000 RPM. And then it goes to 32,000, then it goes to 42,000. That's crazy. The 21,000 is almost double the 12,000 max RPM of the Mori. And that's like where the current starts. You know, I'm just gonna, you know, a little baseline, not that much. All right, check this out. I was just playing with the float here and kind of playing with how it works and where it turns on the pump and where it turns off the pump, because there's gotta be 2 sensors inside there. When it gets low, it turns off the pump, and when it gets to a certain level, it turns on the pump. And check this out. I think I figured out what's happening and why it's being a problem. So all the way down means the coolant is empty, means the pump doesn't have to do anything. It's waiting for it to fill back up again. So if I go up, 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 even here, see, I'm almost all the way at the top. It doesn't do anything. Nothing, 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 right about here. So imagine if chips are getting clogged in this last little 1/4 inch. And then I go up here, and now the pump turned on. And then I drop it, and the pump turned off. Pump turned on. So yeah, I think the floater is floating in the water, and then chips are kind of getting stuck above it. You hear it gurgling. Chips are getting stuck at the top and preventing this thing from going all the way to the top. So that little mistake that I showed in Fusion, where my plastic model is going to hit this tab, is going to be a problem. Like, I can fix it, but it's good that I caught that. It's good to know. Okay, I'm going to clean this up and put it back together because I got parts to make. So I just answered a little question that I was curious about, how high the float sits when it's in water. So just under halfway. It's good to know. Okay, so I've got it going again, no problemo. Cooling off just so you guys can see what's going on, and I know it's air cutting for the first few passes here. Oh yeah, we're actually, there you go. Not quite, I don't know why it's wasting so much. I think I purposely started the tool path outside of the model so that it always hits the model. Doesn't start in the model for any reason whatsoever. And yeah, maybe it takes an extra minute. Whatever. So let's hit the coolant again. That button right there. There we go. Actually, now that we've got this running, we can walk around. And so all that coolant's going down to the chip tray right there. The chip conveyor comes out here. It's sort of, there's a little gap right there where it fills up in the chip conveyor and then it spills into this secondary little container. And then once it gets high enough, should be pretty close. Any second now, this pump is going to turn on. It better turn on. Yeah, like this should be fine for a little while, but those chips are going to get clogged up again. My print finished. I have my 2 halves, my little clamshell design right there. Initial impressions are, I'm pretty happy with how it turned out. I used a 0.35 layer height, which is like super fat layers, fast print. Quality is whatever, it's fine. First impression is I wish I put little pins to be able to kind of clock them together, because when you make 2 halves, they just slip around, they don't clock. But second impression, not necessary, because my tube fits in there perfectly with some gaps still, so the zip ties actually have some compression room, and they stay super lined up with the square shaped tube in there, so it doesn't matter. I'm pretty excited. This is gonna work. It's going to work. Since I don't have time to, like today, to print the mounting bracket, I needed to come up with another solution. So enter the Noga magnetic base. This has a little, I think it's like a retractable magnet inside. So when you turn it to on, the magnet goes, you know, closer to the metal. I think that's how it works. And when it's off, then it comes off the metal super fine. Now I noticed, I never knew this, but the tip actually unscrews and leaves you with a metric M6 thread, which is the mounting screw that I use to mount the bracket on the thing. So I can literally mount the bracket with the whole float sensor on the end of this and adjust my level height to be 4.5 inches, which will just work until I print the bracket and it's perfect. But this will work really well. So let's go do that. One thing I just realized is when I measured the groove thickness, like width, for the zip tie, I measured the zip tie. I did not think about measuring the head. So while the zip tie fits perfectly in that groove, the head kind of does not. It's fine, it's no big deal, but as a wannabe designer, I did that poorly. I could have done that better. So whatever, it doesn't matter, but I always like to notice my flaws in my design so that next time I don't do it. So next time I get smarter. So next time my parts are better. Maybe you can learn from that. I've got a fun little side note for you. This screwdriver is called a Klein, I don't know what model it is, 32,500, whatever that means. It's a Klein screwdriver, and it's not very special. It's not very expensive. It's like, I don't know, 20 or 30 bucks or something, but over the past 20 years that I've been using nice adjustable multi-bit screwdrivers, there's the kind with the cap, and you pull a little bit out, and you put it in the tip, and you put the old one back. There's the kind where you unscrew the cap, and you pour all the bits into your hand, and you find the one you want. I've got all different kinds. This is absolutely my favorite. My buddy Steve gave us like 2 or 3 of them. He buys them by the 10-pack, and he just gives them to everybody, like 5-6 years ago. And it's changed my screwdrivering life. And it's just simple and brilliant. So for example, on this side, you got the Phillips and then flathead on that side. And then you pull the tip bit out and you have the smaller Phillips and smaller flathead. And then you pull the whole shank out. And then on this side, you got the square Robertson on both sides, and you flip that over and you have Torx, 2 different Torx sizes, like probably a 10 and a 15. And then you put it back in. Nothing I've used has been so easy and so fast and so cheap and affordable. And you're just like, oh, no, not that one. Oh, there it is. Yep, that's the one. Go, go, go. Back to work. I don't like fiddling, waiting for dumb stuff. That a clever solution solves that. So the reason I need this is I'm going to pull the electrical panel off, because if I do get those IFM sensors, the $600 ones, apparently that's list price and they're cheaper elsewhere, but if I do get that, I need to know that the voltage actually coming out of the machine matches the 8 to 30 volts that those sensors run on. So, suspicions confirmed. On these switches, they say right on the label, 42 VAC, voltage AC /DC. Now, to me that's confusing, because does it run on AC or does it run on DC? Normally you can't just switch things around. Maybe it doesn't matter, because now that I think about it, this is just a switch. It's an on-off, yes, no, whatever. So I was worried that my system was 42 volts and that the IFM sensors are 8 to 30. But real quick, I'll confirm further, but that says 24 volts right there. So assuming those go to where I think they do, it's a 24 volt system, which means the IFM sensor will work amazing. Obviously we must be careful in here because it's a hot system, hence the don't kill yourself. But if I pull off the cover that covers the wiring harness, I can see those little white wires end up going to those 2 thinner gray cables, which, if I follow everything down, we have thick cables and we have thin cables. And the only 2 thin cables go to these guys. So it makes sense. The thick ones go to things like the transfer pump and probably that one, the chip conveyor motor. So a lot more power going to that. All right, let's test fit it on the ball. I have not done this yet. Oh yes, 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 yes. It's exactly what I wanted. That looks, yes. Good. So notice how I've got it pinched on one side. There's still a gap on this side, which lets the zip tie, gives it some squish. Doesn't need much, it just needs to come off. It needs to not come off. And the ball has this lip around the outside, which is perfect for me, because I put the lip into the 3D print. Now I'm confident that this thing is going to work. Where is my tube? So now once I zip tie it all together with the tube and everything. Okay, suspicions confirmed. Remember I said before, this little pin is going to be a problem. So the pump is not activating right now at the full max position. That's bad. So either I have to cut the pin off until a shorter length, and it'll still work just fine, but then it'll clear my print, or I need to grind the top of my print down, or cut it, or whatever. I'll probably just sand it on the belt sander. Sand that down until the top of the lip here. I didn't think that through ahead of time, but that's okay. Yeah, I'll probably just go grind that off on the grinder right now. Done. Because I want the system to work as designed, which means this metal lip hits the sensor. I can hear the pump turn on, off. So the trigger point must be way up here, ready and on, and then I pull it down. It's got this hysteresis, this dwell zone, and it turns off here. And you can hear it sucking air because the tank's empty now. So it's neat. It turns on and then off again down here. So there are two separate sensors in here. Works good. Now it's going to work even better. As you can see, we're still rocking the ever fancy 1x40 grinder. 1x30. It's not even a cool 1x42. Buddy gave me that. That's probably the first knife making tool I ever got that was given to me by my buddy Sean almost 10 years ago. Still use it, still great. In Eric's shop, they've got a bunch of really nice 2x72 grinders. I've been tempted to get one for here, but just haven't yet. So the 3D printing plastic, PLA plastic, it melts at like, well, you print at what, 215, 210 degrees Celsius? It melts even lower than that. So it feels like a marshmallow right now, like burnt marshmallow on a campfire stick. All right, that was successful, but a little bit more annoying than I thought, because the melted marshmallow, the bigger the glob got, the more difficult it was, and the less grinding was happening, and the more it was just, pushing around the glue. But I'll cut that off with pliers and a knife and stuff, and then it should be good. Meanwhile, Swiss is making pen parts, going awesome. Maury's making Norseman parts. Everybody else has gone home for the night. It's 5:30, and I get the shop to myself, which I love having the shop to myself. So, but I'll get out of here pretty soon. Wrap this up, test it, should be good. Okay, so now that the top has been cut off, I get it to the point where the top of the floaty thingy is sticking out the top of the 3D print, so that I am no longer restricted. So when I go up to the top, pump turns on, pump turns off. Good, 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 good. Okay, let's assemble this thing. The good thing is it's completely reversible. If I don't like it, if it's dumb, if I made a mistake or whatever, I just cut these off and I'm back to square one. I'm liking it so far. Okay, everything's tight. The plastic tube, under reasonable force, I can't get it out. So that's great. And then ultimate test. It spins all the way around. I want to make sure in every orientation it'll clear. Yes, good. I mean, it feels kind of silly on the surface. Like, what are you doing? But it works. Okay, next thing is how to mount this 4.5 inches higher using this guy. Can even use the thumb screw from before. This is just ridiculous. I love it. Oh my goodness, this will actually work. Oh man, okay, so I'm gonna measure 4.5 inches exactly so I get this right, but I have full articulation, full adjustability, tilt, angle, height. Wow. Questionable longevity. If I left it like this for years, like, I don't know, it might fall or something, but that's not the point. The point is, look at this. Okay, so again, I have to adjust the height, and the coolant is really low right now because I kept messing with it. And the thing is off the bottom of the surface, but pump turn on, pump turn off, and that thing should float fine. Holy cow. All right, since my ichrometer is not that accurate, the tape measure will be fine for this. So that's not far. It's probably 4.6, 4.7. So, okay. I'll make this nice though. I'm gonna go around to the control and turn the coolant on. I'm confident that this is actually gonna work. If not, the overflow sensor is gonna hit and it's gonna e-stop the machine. But let's see what happens. Okay, everything's good. Doors closed, everything's good. Coolant on. Coolant on. Let's check it out. Go, 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 go. So, if my math is right, it should float at exactly the same level as it did before. So there should be no adjustment necessary. Give or take half an inch, because the tube and blah, 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 but I don't know. Come on, it hasn't moved yet. Okay, it hasn't moved. I thought by now it would have started moving. Oh, it's so heavy that it's not floating properly. I didn't think about that. Oh no. It's almost neutrally buoyant right there. No! It's gonna e-stop. I'm gonna stop it myself. Son of a, I didn't think how heavy it would be. Okay, so because it's so heavy, I need much more air pocket. I need a bigger floaty. Like a bowl at the end of that would work. All right, should be good. Let's turn the coolant off. Man, one variable, weight, that didn't enter my brain. I was like, oh, it's just gonna float. Need more surface area, more displacement of water. Okay, that's a result. That's good. Results are good. It further proves that I should really stop wasting my time and just get that IFM sensor, and now I know how to wire it in because I saw the wiring. It's not a big deal, and I should just buy it and do it. But the persistent side of me wants to get this to work. Oh, I feel super dumb that it didn't work, but that's the development process. Okay. You know what? I'm looking at this right now because I'm hungry. This kind of surface area. Dude, if I super glued this container to the bottom of the little end mill container, we're better. I might actually do, I'm not this hungry, but a yogurt tub. Okay, well, we got some ideas here. Let me think. You know what? Okay, watch this. Yogurt tub, it's already got chips in it. Let's see what happens. Theoretically, if the water is constantly pushing that thing upward, there we go. For a test, it doesn't even have to be glued or attached or anything. I just put it under, the water's gonna push it up, and let's see. Okay. getting there. This might work. I'm gonna turn the coolant on, let's see. Okay. It's rubbing this side, so this is not ideal. And if it goes up too high, it's gonna hit the Noga base. But it is moving. It's creeping. It's like sticking just a little bit. Almost there, and go. Success. Well, now it's dropping. Do I trust this for an unattended night run? That is the question. Real talk time. Maybe I do it different than everybody else. Maybe I'm weird, maybe I'm doing it wrong. But the way that I tend to design things and prove out new ideas, it's messy, it's wrong, it's bad. You find everything that's wrong with it, and it gets better and better over time. That's just the way that I do it. You know, you want everything to be polished and perfect and like put a little shiny ding on it for Instagram and look like you're awesome. But the fact of the reality is, I try things, I think they're gonna work, I end up forgetting something, and I find out why it didn't work, and then I learn, and then I repeat. And then eventually, with enough persistence and perseverance, I figure it out, and it works, and it's done. And that helps me innovate, it helps me drive new ideas, it helps me come up with new crazy stuff. It helped me build this entire company that now employs 10 people and has a lot of fun doing it. And I get to fiddle with things like this so that I can run my machines at night consistently. So this feels really dumb right now because I have a yogurt tub on there and it's not good, but darn it, it's working. It's gone through probably 6 or 7 cycles already. It's functioning. What is the pretty version of this? That's what I have to figure out next. So it's almost embarrassing that I forgot the variable of weight and whatever you call it, surface area, floating, whatever. I'm not an engineer, but I learned. That's all. What I did, I stuffed the tub full of paper towels around the 3D printed floaty thingy. Paper towels add minimal weight and they allowed me to like stabilize it in there. And it's been running for a while now and I'm happy with it. It's not forever and I'm gonna make it better and I'm probably gonna get the laser guided digital thingamajigger, but I'll trust this tonight. The worst I can see right now, like coolant never really splashes to the top to where all the paper towels are, so I'm not worried about that. I'm worried about them maybe expanding and like getting loose over time and falling out. And if they come up over the edge and start wicking coolant into them, then it'll get heavier and it just won't work as well. And then the overflow sensor is going to trip. So worst case, I'm no worse off than I was before with an unreliable float sensor. Now I have a slightly more reliable, hopefully very reliable float sensor. So, I mean, I'm pretty happy about that. Is it perfect? No. Is it functional? I do think so. So that was today's project. I did a bunch of other stuff too, I just didn't talk about it. But, good. I think I'm gonna order that sensor. But anyway, yeah. I'm gonna run this tonight. Should have a, what are we doing tonight? Probably a 12-hour cycle, if it all works. If this doesn't alarm out, if I don't break a tool, if everything works, it should be a 12-hour cycle, which means it'll still be running tomorrow when somebody comes in first thing. That's exciting. Okay, let's do that. Bye guys, thanks for watching. Wait, one more thing. Quick update, it's the next day. Successfully finished a 10-hour run. I'm super excited. Check this out. It worked. It worked so well. And I want you to look at how many chips ended up stuck to the bottom of this thing. All those chips would have been stuck to the probe, to the sensor floaty thingy, but now they get to stuck to the yogurt tub, which do nothing to hinder the performance of it. It works. It works so good. I'm excited. There you go. I still feel like I need to find a more permanent solution, but I temporarily super happy, stoked.